All right, so 5.4, we're going to continue our study of polynomials. To figure out what that word means, so just here's some examples. They have little exponents that are numbers, it's like second degree, first degree. And today we're going to learn how to divide them using something called synthetic division. And along the way, I'll talk about what's called like long division, which you don't really need for this next test or anything, but I just wanted to contrast it with synthetic division, which is a lot easier. And actually, the synthetic process is pretty easy. It's just going to be used to divide two polynomials. Okay, I was shooting this on a Friday, and I had this in there, so I figured I'd put this up here. Um, at any rate, uh, yeah, I have no idea when you're watching this. So I'll come back and do long division later on these. But for now, if you want to jot this one down, we'll talk about how to divide these with synthetic division. And before we get too far into it, like when you divide like regular numbers, like if I did 41 divided by 5, you might get 8 with like a remainder of 1, right? There'd be 8 fives in 41, and then you'd have 1 left over. So they'll write it like that, and then write it 8 with 1/5 left over, like 1 divided by 5. So you'll see that a little bit in our answers here, where you'll have this what's called the remainder, the leftover part when you divide. And I'm going to write it this first way in this video. All right, so at any rate, how you do synthetic division is just a process where it's kind of mathematical magic. Like if you wanted me to go into why this works, then I can make a 78-minute video and you can watch that if you really want. But it's basically a process where you make a window and then this long line. And what you do is in the window goes the answer, which in later lessons that'll be significant. But it kind of comes from like, if this thing is a factor, right? We talked about in the previous lessons, like if you factor something to like x plus 5 times x minus 3 equals 0, then your two answers are -5 and +3. Okay, so when we put the window, I'm going to say like if you set this to 0, what would be your answer? And so that answer goes in the window of -5. All right, so I'm going to call that the answer if this were a little factor. Okay, and then along the top, you just put these coefficients in order. So I'm going to put 4, 23, and -16. All right, and then synthetic division is just a process. So the first thing is you drop the first number all the way down here. So 4. And then to get the next number here that goes under the 23, you do -5 times 4. It's -20. And then you add these together. And then that process just repeats. So to get the next number, I multiply with the window, add these, all right? And so this is our answer down here, the 4, 3, and -31. And we just have to identify what they are. So this last thing will always be the remainder. And then this thing will be the constant. And I'm going actually right to left. This will be x to the first, and then x squared if we had any, and then x cubed, etc., etc. Right, we don't have any x squared or x cubed, but I just wrote them there as an example. So when we divide these two things, we get an answer of 4x plus 3 and a remainder of -31, right? And it kind of makes sense if you have an x squared divided by a linear that lowers the exponent by 1, so you get an x to the first, right? So it's just a weird way of dividing that's a lot better than long division, which I'll show at the end of this video. Okay, so let's try one more straightforward example like this. Give you a chance to copy it down in the notes. Give it a shot. Okay, so I'm going to draw this big window thing. And into the window again, sometimes students want to put 2, but it's the answer. If I set this to 0 and solved it, I would have -2 goes in the window. Coefficients along the top, 1, -14, 51, and -54. Okay, so again, try to do this process, right? If you haven't tried this already, see if you can remember the process from here. The first one's a little different. You drop the 1, but then it's the same process every time. Multiply with the window, add going down, multiply with the window, add going down, multiply with the window, add going down. All right, and so we get negative 220. Okay, and again, this is our answer. So going right to left, this thing is our remainder. The last thing is our remainder. It's our constant, our x term, and our x squared. So in the end, when we divide these two, the exponent lowers by 1. So now we have a 1x squared, a 16x, a constant of 83, with a remainder of negative 220. Okay, and that's pretty much it, right? That's the process. Again, we get something 1 less. We start with a cube divided by an x to the first, so we have 1 less in our answer. We went from a cubic to a quadratic. All right, so this one's got an important twist, and there's one of these like on the test. So it's different how you set it up. So I'm going to give you a minute to see if you can figure out how you would set up this problem and try and figure out how is it different than the other ones we've done so far. All right, so again, into the window goes our answer. So if I set this to 0, it'd be 4. And then along the top, you have to go in order. So it goes x cubed, x squared, x to the first, and constant. So what's different about this one is we don't have the x squared. It's like a gap. So when we do our coefficients, we have to do 1x cubed, no x squareds, 3 x's, and then a constant of negative 12. So basically, there'll be one on the test where there's a gap like this, and you have to remember to put the 0 in that gap spot. All right, then it's the same process as before. Drop down the 1, multiply with the window, 1 times 4, add, going down, 4 times 4, add, that's 19, multiply with the window, that would be, let's see, 76, and then add these together, and that would be 64. Right, and then what we're left with is the remainder, the constant, the x to the first, and the x squared. So again, we start with an x cubed and got 1 lower. So we have x squared plus 4x plus 19 with remainder 64. Okay, so that's kind of the guts of this lesson, and it's that's basically it. I have a couple other things here that I think are important to understand, but the main thing is this process, but then I have some kind of like additional facts. Okay, so the first thing I want to say is you can actually use this process to factor, right? So that's kind of the next step in the process, is to be able to factor using this synthetic division, which seems weird, but basically, like if I take a number like 40 and give me any number that divides 40. In class, I'd usually ask a student here, but let's say the student said 4. Okay, so we know that 40 divides 4. So what we can do is say, okay, if 4 divides it evenly, divide it and get our answer of 10. And then because it divided evenly, we can take these two things and say, well, that's actually a factorization of 40, right? Whatever we divided by multiplied with our answer must equal what we started with. All right, so in this way, knowing that 4 evenly divided it allowed us to factor 40. Okay, so similarly, if we know that this was a factor, right, that it evenly divided it, then we would know one of our answers is negative 5, like we did before, right? If that's a factor, set it to 0 and get negative 5. So knowing that that's an answer, we can take that answer and synthetically divide it out and then solve what remains. So here we would have, if we do synthetic division 1, 11, and 30, we would drop the 1, multiply with the window, add these together, 6, and then multiply with the window. And this is the first time this happened for us, is we actually got remainder 0. So that's just basically saying it divided evenly, right? Like in this case, 40 divided by 4 is 10 with remainder 0. So it divided out evenly, and what we were left with is 1x and a constant of 6. All right, so now that we know that this is our answer, right? When we divided, let me write this out real quick then. So when we divided x squared plus 11x plus 30 by x plus 5, we got x plus 6. Okay, so just like we did in this example with 40, because it divided evenly, it would be accurate to say that x squared plus 11x plus 30 is equal to what we divided by multiplied by with our solution, which is x plus 6. Okay, so in that way, we were able to factor then this statement into these two things. Okay, and if it were a solved question, we would have now factored it apart. Okay, and then we could set those little parts to 0 and get our two answers. All right, so I know on this one, you probably could have factored without doing all of that crazy synthetic division, but on a harder question, as we get higher level polynomials like x to the fifth, if we can find answers, like if we can find an answer of -5, we can divide out this factor, and then we'll be left with an x to the fourth, and we'll be one step closer to finding all the answers. Okay, so that's kind of confusing, but it's a good preview for what's coming next. Right, we're going to use synthetic division to factor apart polynomials and then solve it from there. All right, final thing I want to cover in this video is I promised to go over what long division looks like. So this synthetic division is really handy, especially when you consider what long division looks like. So maybe let's do an example. If you want to remember how long division works, if I take, like, let's say 451 and divide that by, I don't know, like 3 or whatever. How long division works is you say how many times does 3 go into 4 once, and then you multiply 3 times 1, subtract to get 1, bring down this 5. How many times does 3 go into 15? That would be 5 times. Multiply down again to get 15. Minus this, you get 0, bring down the 1. How many times does 3 go into 1? It doesn't, so it goes in 0 times. Right, so we minus 0, and then our remainder is just going to be 1. So 451 divided by 3 is just 150 with remainder 1. Okay, there's our answer. Okay, so we're going to do this process except now with polynomials. So this is kind of fun if you want to torture yourself, or I don't know, on certain questions you can't do synthetic division, so it's good to do long division. It won't come up again in Algebra 2, but in a future math class it certainly could. All right, so we're going to draw this bad boy out. So I'm going to take 4x squared plus 23x minus 16 and divide that by x plus 5. And the process is exactly the same as over here. So we're going to take, how many times is x, just looking at the first parts, how many times is x going to 4x squared? And that is 4x. I'm essentially going to take 4x squared divided by x. Okay, now I'm going to multiply down. So I'm going to take 4x times x plus 5, and that would be 4x squared and 20x, right? And now we want to subtract those off, what we have. So that's good because the 4x squareds are now canceled. And 23x minus 20x is 3x. Okay, and now we bring down the minus 16. And we say, okay, how many times does x go into 3x? And so that would be 3. Right, take 3x divided by x. And then multiply down again, 3 times x plus 5. And you get 3x plus 15. Subtract that off, so that cancels, and then negative 16 take away 15 is negative 31, and that's our remainder. Okay, so when we divide these polynomials, that's our answer, which is the same we got over here, but it was just a lot easier with synthetic division. So long division is a pain, but I just thought I'd show it to you and show why synthetic division is so much better. All right, that concludes it. Again, the main thing is that you know how to do this synthetic division. There was stuff at the end that was just to kind of help you with future lessons or classes. All right, take care. Thanks for watching.